Hello Year 11s and welcome back to Mathematics. In today's lesson, I'm going to be continuing with our topic of algebra, and in particular, we're going to be working with a bit of surds. We're going to be working with some surd laws and operations with surds. In today's lesson, we're going to be doing just a basic operation with surds, and then in the next lesson, we're going to be doing something called rationalizing the denominator. I think some of you may have seen this in Year 10. I'm going to go through it in a bit more detail as well, and just give you guys a chance to go and get some practice on it as well. So let's just go through surds. So this is on page 39 in your booklets. So by the end of today's lesson, we want to be able to simplify surds, rewrite surds in the lowest base, and rationalizing. We'll look at rationalizing later, and we're going to be using surd laws. Okay, so definition 5. So a surd, just so we know what we're talking about, surd is a number in the form the nth root of a number x, which cannot be written as a rational number. So for example, square root 2. We've looked at square roots before, so for example, if we wanted to square root 9 actually has an answer, which is 3. However, not every number that we square root has a number that we can write as a neat number. So for example, if I put square root 2 in the calculator, what you notice is that it has this number 1.414213562. The calculator doesn't have enough digits to show, but this number actually goes on and on and on and on and on and on and on forever and ever and ever. This is called an irrational number. It's a number that can't be represented as a fraction. And so for these particular cases, we call them surds. And often what we like to do is just leave it in that square root form and do operations with it because it's a lot neater to do so. So that is what a surd is. Now, when we're trying to simplify surds, what we're going to first look at is simplifying, then we're going to be looking at adding and subtracting, and then finally multiplying with surds. So, basic arithmetic with surds. So the first thing we're going to look at is simplifying with surds. When we have a surd, what we want to do, we want to fully simplify surds by finding their greatest or highest, I'm going to make a note here, or highest perfect square factor. So when we have a surd, what we want to do is we want to look at numbers which can divide that particular number in our surd and are perfect squares. So we want to find numbers like 4, which is 2 squared, 9, which is 3 squared, 16, what's the next one, 25, 36, 49, 64, and so on. So we want to see if the number underneath our inside our surd can be divided by one of these perfect squares. And by doing that, we can actually take that perfect square out. And because we can actually square root these numbers and it gives us a whole number, we can actually pull that out from our number. So let's have a look at the examples underneath. Simplify the following expressions involving surds. So let's have a look at the first one. A, square root 108. 108 has a few factors that you might be able to pick up. For example, you might notice that square root 108 is just 9 times 12. And so hopefully you can see 9 is actually a perfect square number. However, there's actually a bigger number that is bigger than that. This is actually, 108 is actually, can be written as 36 times 3. If I do this in my calculator, 36 times 3 is going to be give me 108. And so what I can do is I can actually take out that 36, because 36 is a perfect square. 36 is just 6 square. And so what I can do is I can take that 36 out of that square root and just rewrite this as 6 square root 3. I can rewrite my surds by taking out that perfect square factor and just pull out the front and just write the square root value there. So here I took out the 36, the square root 36, which gave me the 6, and so I'm left with 6 root 3. Okay, let's have a look at the next example. B, I've got 5 root 27. So once again, I'm looking at my square root, that square root 27, and I want to find a perfect square factor, a square number that can divide that particular number. In this case, well, hopefully you can notice that 27 is just 9 times 3. And so I can take out a 9. So here, this is going to be 9 times 3. And so I can take out that 9. The square root of 9 is 3. And so this becomes 5 times 3 root 3. And on the outside, I can actually simplify that 5 times 3, 5 times 3 gives me 15, and so this just becomes 15 square root 3. Okay, so here once again we're taking out that perfect square factor. Now with the working out, if you can jump from this step straight to this step, you can do that. I just wrote out these additional steps just so you can see what I did here in separating 27 into 9 and 3, and then pulling out that square root 9, which is 3 out to the front, and then multiplying the 2 at the end. Okay, let's have a look at C. Now C is 216. Now with 216, if you're not able to find a perfect square factor, I'm going to show you something. We can actually repeat this process a few times, just like you would if you're simplifying fractions. And so here, 216, you might be going, I can't find a perfect factor. I can start small. I can go, okay, actually, 4 is a factor of this. So this is actually 4 times. So if I divide 216 by 4, I actually get 54. And so I can take out that 4. The square root of 4 is 2. So I'm going to get 2 root 54. But then once again, I can repeat that process with 54. 54 is actually a fairly big number. Let me just think of my square root factors. So 54 is actually 9 times 6. And so I can actually take out that square root of 9. So square root of 9 is 3. So I multiply that with that 2. I get 6 root. And what's left over in my bracket, in my square root, is a 6. And so here, actually, let me add on that step just so you can see what we did. If I can get my button to work here. There we go. It's a bit laggy, that's okay. Nope, it's not going to cooperate, that's okay. I can actually write this as 2 times square root 9 times 6, and which is why I get that 6 root 6 in the end. So when we're simplifying surds, what we want to do is find the greatest perfect square factor. Find the biggest number, which is a factor of the number inside our surd, and is also a perfect square. We can take it out, take the square root, and then move it out to the front. So that's how we can simplify surds. Okay, so that's the first bit of our arithmetic with surds that we need to have a look at. The second thing that we're going to be doing is we're going to be doing addition and subtraction with surds. Now here I have actually forgotten to put a heading for that, but I've got a bit of a note here. So here, if you have a look at the note, just like algebraic terms, surds can be added or subtracted. So just give me 2 seconds to check something. Okay, cool. That's working. Okay, so just like algebraic terms, surds can be collected by adding and subtracting. So we can actually add and subtract like surds. So in order to do that, we actually need to make sure that our surds have the same number. Let me do a different number here. If we have 2 surds where under the square root there is the same number, so let's say I have square root a and I've got another 2 square root a, we can treat these square root a's as like terms and actually combine these like we would with algebraic terms. And so here we would get 3 square root a because we have 1 square root a in the first term and then 2 square root a's in the second term, and when we add them together we're going to get 3 root a. Okay, so let's have a go at simplifying the following example. So here, simplify the surds and then collect like terms. So here we've got square root 44 minus square root 99. If you have a look at these two numbers, hopefully you notice they don't have the same number under the surd. So we can't just add them, or in this case, subtract them immediately. What we need to do is actually we need to simplify these surds. So let's have a look at the first number. Hopefully you can tell. 44 has a factor of 4. That's a perfect square number. And so I can take out that 4 to the front. And so the square root of 4 is 2. So this becomes 2 square root 11 minus. And similarly, 99 also has a perfect square factor, which is 9. Square root of 9 is 3. So this just becomes 3 root 11. And now notice that we have square root 11 and square root 11. These are, we can actually combine these together. Now the answer is a bit off because I think this should have been a plus. But in this particular case, if we minus them, we're going to get, we've got 2 minus 3, which gives me minus 1. So this will give me negative square root 11. So here, we want to just make sure that we simplify our surds where possible, and then we can try and add and subtract them. Okay, let's have a look at the next example. Example under here, fully simplify. We've got square root 72 minus square root 50 plus square root 12. Okay, so let's go through this example. Square root 72. Come on, erase. This isn't erasing, that's a bit annoying. It's okay. Minus square root 50 plus square root 12. There we go. Okay. So, once again, the square roots, they don't have the same number underneath. So what we're going to need to do is we need to actually simplify our surds. So let's simplify our surds. So 72. What's a perfect square factor of 72? Well, actually, half of 72 is 36. So 72 can be just written as 36 times 2. 36 is a perfect square, which is just 6 squared. So this 72 just becomes 6 root 2. Okay, let's repeat the process for the next two. So 50 actually has a perfect square factor of 25. 25 is just 5 squared, and 50 is just 25 times 2. So once again, I can take the square that 25 out. So square root of 25 is 5, so I'm going to have 5 root 2 plus, now 12 has the perfect square factor of 4. 4 divides into 12, so 12 is 4 times 3. I can pull out that 12. The square root of 4 is 2, so this becomes 2 square root 3. Okay, now I can start to add and subtract our surds. Here in this case, we've got 6 root 2 and a 5 root 2, which are like surds. So 6 minus 5 will give me 1, so this just becomes square root 2 plus 2 root 3. I can't combine that 2 root 3 because it's not a like surd. There's no, it doesn't have the same number underneath the surd, so I have to actually just leave it as 2 root 3. Okay, so that's how we add and subtract surds. So usually what you'll need to do is simplify our surds first by taking out a perfect square factor and then move adding and subtracting like we would with algebraic terms. Okay, let's have a look at the next section. Now with the next section, we're going to be looking at multiplication with surds. Now when you are multiplying surds, if you have two surds, what we can do is we can multiply the numbers inside this square root together. So if I have two surds, so square root a times square root b, we can just multiply together the two terms inside the square root and just write it together. So let's have a go at this example here. So simplify each of these products. So here for this first example, we've got square root 15 times 5. So I've got, let me just move my laptop back to the right spot. Give me 2 seconds. Okay, there we go. Just needs a bit of time to load. Okay, square root 15 times square root 5. Well, 5 times 15, I can do that. So 5 times 15, that will just give me 75. And so here we can actually multiply the two together. After we've done that though, we always want to check whether or not we can take out a perfect square factor. Now 75 does have a perfect square factor. 75 is just 25 times 3. And so we can pull out that 25, which is 5 squared, out. So I can rewrite this as 5 root 3 because we just wanted to know, just make sure we know this is just 25 times 3. Okay, so that's how we can multiply with surds. Let's have a look at the next example. So here for part B, we've got 5 root 6 times 7 root 10. Okay, now notice here for these surds, we've got numbers outside the surds. And so what we can do is we can multiply those numbers separately and then also multiply numbers inside the surd separately as well. So here I've got 5 root 6 times 7 root 10. I can do this 5 times 7 first. So 5 times 7 will give me 35. And then inside the surd, we're going to have 6 times 10. So 6 times 10, that's going to give me 60. And just like we did before, we just want to check whether or not there are any perfect square factors of 60. So let's think about that. So square root of 60 can actually be written as 4 times 15. 4 is a perfect square factor, which when we take the square root of it, will give me 2. So this just becomes 35 times 2 root 15. And so this becomes 70 root 15. And so that's how we can multiply with surds. So once again here, multiply the numbers inside the surds together and multiply the numbers on the outside of the surds together. Okay, we can also extend this with binomial products. So if you remember, we used the crab clause or the FOIL method to help us expand expressions where there are brackets involved. So we can actually do that with surds as well. So for this next example over the page on page 41, we want to expand and fully simplify the following expression. So here we've got square root 15 plus 2 times square root 3 minus 3. Now here we can use the crab clause or the FOIL method, whatever you were taught. So here I'm going to do that first term multiplied by every term in the second bracket. So I've got square root 15. So it's going to be square root 15 times square root 3. So I'm just going to multiply the numbers inside the surd, so this becomes square root 45. Now the second one, I've got the square root 15 times 3. So when I multiply that, I just get 3 root 15. That 3 is not inside the square root, so I don't need to actually write that. I can't multiply it inside there. Okay, let's look at the next term. So I want to do the same thing for my second term inside my bracket. So here I've got the 2, and I multiply with all the terms there. So the next term is just going to be 2 square root 3. Because I do the 2 times the square root 3, and I've also got the minus 3, so it's going to be minus 2 times 3, which is 6. Then from here, we just want to check all our terms and see if there's any terms that we can simplify. Now, the one that I kind of see immediately is that square root 45, mainly it's because it's the biggest number, and I can immediately see that there's a perfect square factor. Square root 45 actually has a perfect square factor of 9. 9 times 5 will give me 45, so I can take out that 9. The square root of 9 is 3, so this just becomes 3 root 5 minus 3 root 15 plus 2 root 3 minus 6. Now here, are there any like surds that we can combine? If you have a look at all the surds, there's no common number underneath all the surds, so we can actually leave this expression as it is. So here we can actually expand and simplify our surds just like we would with normal algebraic binomial products. Now the last example I'm going to go through in this video is this example over here where we're going to expand and simplify this perfect square. Now if you notice, I've got this perfect square, and we can actually apply that perfect square expansion. If you remember from earlier in the algebraic topic, if we've got a minus b all squared, this just becomes a squared minus 2ab plus b squared. And so I can use this expansion on this expression, even if it has surds. So let's have a look at this example. So square root 15 minus square root 6 all squared. Using this expansion, what I'm going to do is I'm going to square the first term. So that's what this a squared tells me. I'm just going to square the first term. So it's going to be square root 15 all squared minus 2 times ab. So I just multiply the two terms together. So here's square root 15 times square root 6 plus, and the last term is just b squared. So the second term inside my bracket, 6 all squared. Now when I deal with this, so notice square rooting and squaring are opposite operations. So when I do this first and last term, I'm just going to get rid of the square root. So here's going to be 15, and at the end it's going to be a plus 6. Okay, now the middle term, we just need to multiply the surd. So here this is going to be 2 square root. 15 times 6 is actually going to give me 90. And so here I can actually start to simplify a few things. First of all, the numbers, I've got a 15 and a 6 lone terms, so I can just add them together. So this will give me 21 minus, and I look at that surd, square root 90. Now, 90 has a perfect square factor. 9 is actually a factor of 90. 9 times 10 will give me 90, so I can take that 9 out. The square root of 9 is 3, and so I can take out that 3, and so this just becomes 6 root 10 with what's left over. And that's how we can do some basic arithmetic involving surds. Now I know that I've gone through this quite quickly, so if you need to go back and have a look at any particular part, feel free to do so. There are a few questions for you to have a go at on your own. Next lesson I'll have a look at rationalizing the denominator, because this is I'm going to treat this as a separate thing. It is requires a bit more additional work. So have a go at the questions, and if you're stuck, feel free to send me an email and I'll help you out. Until next lesson, year 11s, I'll see you then. Bye.